Okay, I want to try to make this pretty quick, but make it useful for you. What I want to show you is how you can graph multiple functions all on one graph, which is a really useful way to graph your asymptotes along with your rational function. And then you can really make sure that the function that you're creating is indeed going to those asymptotes. Especially helpful for the horizontal asymptotes that are oblique, that are lines that have a little bit of a like diagonal lines, because those are sometimes tough to tell if it's actually where you think it is. So let's just pretend we're doing a problem, kind of like one of these problems you have to work, where you have I give you some of the asymptotes, then you have to figure out the function. So let's say I say, first of all, I want your asymptote to have a vertical asymptote at, say, x equals 3. So the first thing I'm going to do is I'm going to go ahead and graph x equals 3. So I know what I'm looking at. That's the asymptote, right? Just a big vertical line. And so the next thing is I want to do is I can click here and I can add a new function so they can both be in the same graph. And let's say the second thing is I want to have a horizontal asymptote that's oblique that has the equation of a line. How about y equals 4x minus 5? So that's a nice line. The minus 5 takes you, that's your y-intercept. You can also write in here y equals, if that makes it better. It doesn't really matter. That's the y equals is kind of implicit. It's already built into that. So there's that line, a slope of 4. So rise up 4, run over 1, and then it's crossing the x or the y-axis at -5. That's the b. So those are my two asymptotes. Now I want to try to create a function that matches that. So you're going to have to kind of work backwards. Now think about this. The first thing you know is the vertical asymptote comes from the restricted value of x. So if I have a x equals 3, I know in my final function I'm going to have something on top. I'm just going to start it out. Divided by, now what's going to go on the bottom? It's going to be x minus 3, right? X minus 3 is going to give me that that asymptote, that vertical asymptote. And you can see in this function, just x divided by x minus 3, I have that asymptote. Now how do you create a function that has a vertical or that has a horizontal asymptote that's in the equation of a line, that's an oblique? And if you remember, it's when you make the numerator one more degree, so like a squared. Now that would give me a irrational function with an oblique. And you can see by this one, it looks like the oblique thing is somewhere around, I don't know, maybe around 3 or 4, somewhere around there. It's not the line I want it to be on. I want it to be on this line. So how are you going to do that? This is it's an interesting problem. You're kind of working backwards. So I want you to think about this a little bit. Just listen and think. I know that if you remember, the way you can get this exact, if I wanted to say calculate this particular function, the asymptote, you would divide the numerator into the denominator, and the quotient that you get is the line. So in other words, if I want to divide x minus 3 into something on top, I don't know what that's going to be, it's going to equal 4x minus 5. And then there's going to be some kind of remainder at the end. Now that's important. So if you think about that again. This x minus 3 divided into something, I don't know what I'm going to divide it into, I have to figure that out, but I know what it equals. So plus a remainder, and I'm just going to kind of forget about the remainder for now. So what you can do then is multiply this times x minus 3, and that's going to give me a very good answer on top. So let's just do that. I'm just going to do that in my head out loud here. You can hopefully follow along. So 4x times x is going to be 4x squared. So I'm pretty confident about that one. And then I'm going to have 4x minus 3 is negative 12x. Negative 5 times negative x is negative 5. So negative 17x in the middle term. And then I'm going to have negative 5 times negative 3 is going to be positive 15. Now, did you see what happened when I did that? I don't know if you noticed. It graphed this new function directly over the line. So it is the line. How would that happen? Well, think about what we did. We took this guy, this denominator, multiplied it by this, and we got this. So if you take this big old thing, divide it by this, you can essentially come right back to that. Okay, hopefully you're following me. That's a little bit weird. So what I want to do, this is no good. I need to just make a little change to this. This is where you just change this to anything you want, because what really is important is just the first two terms. And when you're making these oblique asymptotes, so if you just add that to say plus 5, now what happens, it makes some funky, crazy, irrational function. The vertical asymptote looks good. And if you scale back, you can see there's the horizontal asymptote, oblique. There's on the left side. And if you come up here on the right, it's going closer and closer. So pretty cool. So this third term, you can make anything you want. You could play around that, change the shape a little bit, make it minus 5. Doesn't change too much. Make it minus 25. You know, it's making little changes. But in the end, the big thing is it keeps the vertical asymptote and it keeps that oblique asymptote. So hopefully you follow along. The important thing is I want you to know is just remember that, well, I was just watching that big hit in the football game. Remember, what I want you to be able to do is graph all 3 of your functions all at once, your asymptotes, and if you have more asymptotes, you can graph those. And that way you can get a nice visual check to make sure your irrational functions are indeed going towards those asymptotes.